Okay, this is Module 5, Problem 104. It's about a principal or the chair of the department who can only retain one of two instructors and would like to get ratings from students to help his decision. It says how many groups or conditions are there in this experiment? There are two. Are the two groups or conditions in this experiment defined by the experimenter, or do they represent two naturally defined categories of subjects? Because the principal didn't assign students to an instructor's class at random, so the experimenter didn't introduce the variable or manipulation or factor of interest. They occurred naturally, so this is a naturally defined experiment. What kind of two-group or two-condition design is this? Because the groups are independent, it's a between subjects design. Another way of saying it is an independent random sampling design. Okay. How many measures are there for a subject in any one condition? One rating is taken per person. Are the measures or outcomes in this experiment categorical, binary, or continuous? Because the ratings can range between a minimum of 0 and 100 and can take on any value in between. They're certainly not binary, but they are continuous. So I just don't want to make a spelling mistake here. I'll just copy and paste. Makes it easier. Are the measures in this experiment independent of each other? Now, normally you would say yes, but in this case, the principal or the chair wants to save time, so all the students give their ratings out loud. So the rating of one student may influence the rating of another student. So the ratings are not independent. The answer is no. And because of this, we should terminate this experiment. Okay. Second problem. This is an experiment that's interested in whether caffeine would affect reaction time on a driving simulation task. To determine this, he randomly selects 10 subjects. Okay, participants was tested once after having drunk 4 cups of coffee 1 hour before the test, and once, abstaining from caffeine for 24 hours. 1 week separated the two tests. Okay, got it. Analyze the data. All right. C is for the no caffeine. Okay. How many groups or conditions are there in this experiment? Well, there's a caffeinated group and the non-caffeinated group. Even though it's the same group of subjects, I'm going to say 2 and hope for the best. Okay, so that's correct. Are the two groups or two conditions or two members of a pair defined by the experimenter, or do they represent two naturally defined categories of subjects? Because the caffeine versus no caffeine condition is defined by the experimenter, I'm going to put experimenter defined. People didn't walk in to the lab um, with caffeine in their blood or not, as if that was determined by, as if it was naturally determined. So it's experimenter defined. Okay, the two conditions. All right. It's what kind of two group design is this? This is a within subjects design or a match. Well, it's not really a match pairs. It's a design because there are no pairs, but it's a within. I'm going to type in within subject, and hopefully that's correct. Okay, so it is correct. There's no S at the end of it. This is a special case of a match pairs design called a within subject design because each subject in the experiment appears in both experimental groups. Okay, how many measures are there for a subject in any one condition? There's a single measurement per subject per condition. Are the measures or outcomes in this experiment categorical, binary, or continuous? Reaction times can take on any value between a theoretical minimum and maximum, so the measurements are continuous. Okay, are the measures in this experiment independent of each other? The measurements, you would think because it's the same subject that they wouldn't be independent, but because in one condition you have caffeine and the other one you don't, and there's a week in between, uh, and the conditions are counterbalanced, etc., etc., I'm going to say that they are independent. What is the appropriate test to employ with this experimental design? We have um, a within subject design, or as was written in the module, a special case of a match pairs design. So the two options would be a sign test or a sum of positive ranks. Because we have continuous data, we have to use the sum of positive ranks. If we had binary data, it would be the sign test. So I'm going to put in B. What is the appropriate test statistic? The choice A is E's before C's. Choice C is Y, the number of successes in N trials. B is the sum of positive ranks. The next step is to complete the difference scores. Okay, so you're just subtracting column C from column E. So I'm going to do that here. That's 3. That's 6. Okay, that's -3. Okay, hopefully that's correct. And it is. Okay, good.